Have you ever stopped to think, I mean, just how much further can we really push computing power? We've seen things go from, machines filling entire rooms down to incredible power we carry in our pockets. But what's the next big jump? And how does one company seem to consistently lead the way? Today, we're diving deep into TSMC's groundbreaking SoW-X technology. And this isn't just like a small step forward. It feels more like a fundamental rethink of how we build high-performance computing systems. Our goal here is to really pull out the key insights from the sources we've looked at, give you a clear picture of what SoW-X actually is, its potential impact, which sounds huge, and what kinds of shifts it might bring to the whole tech world. Think of this as maybe you shortcut to getting up to speed on a really complex, really cutting-edge piece of semiconductor innovation. Let's jump in.
Okay, so first things first, what exactly is this TSMC SoW-X?
Right, so WX, it stands for System on Wafer Extended, and really is a forward-looking approach to wafer-level packaging. TSMC officially pulled back the curtain on it at the 2024 European OIP Forum. And what's pretty striking is the timeline they're aiming for. Mass production expected in 2027.
2027. Okay. And the performance claims are, well, they sound pretty bold, right? I think our sources mentioned. So WX is projected to boost computing power by up to 40 times compared to what we have now. That's just an enormous leap. Can you maybe help put that kind of improvement into context? 40 times.
40 times is, it's a massive claim. And the core innovation making that possible is this substrate-less packaging idea. That's what really sets it apart from older tech like CoWoS. Essentially, the redistribution layer, the RDL, it's fabricated directly onto the wafer itself. So that traditional substrate layer, it's just gone, removed completely.
Right. Okay. So getting rid of the substrate. What are the big practical wins TSMC gets from doing that?
Well, removing the substrate lets them pack things much, much more densely. Higher integration.
Yeah.
And critically, it also means significantly better power delivery and thermal management. Heat is a huge issue.
Always is with more power.
Exactly. And give you a sense of scale here. So WX can potentially package up to, say, 16 ASICs. Those are application-specific integrated circuits, plus dozens of high-bandwidth memory modules, HBM, and even things like photonic transceivers. All of that integrated onto a single 300-millimeter wafer.
Wow.
The actual physical area for packaging is vast. We're talking 7,722 square millimeters, which is roughly 9 times the size of a standard reticle.
9 times a reticle. Okay, for listeners, the reticle is like the stencil, right? For printing the circuits.
Precisely. So that gives you an idea of just how much integrated real estate we're talking about here. It's huge.
So this really goes beyond just sticking more chips close together. It sounds like a more holistic idea, packaging as a system. Is that fair?
That's exactly it, yeah. What's really fascinating, I think, is how SoW-X represents a major strategic shift, a pivot in semiconductor design thinking. We're moving past the old focus on just the single chip. This is about true system-level integration.
So what does that look like practically?
Well, imagine GPUs and HBM memory maybe not even being separate components on a board anymore. With SoW-X, it's almost like the motherboard design itself gets embedded right into the wafer. You could potentially stack entire AI accelerators as these pre-integrated system modules. And this fundamentally changes TSMC's role, right? They're not just a foundry making chips anymore. They become a provider of these highly integrated computing platforms, a dominant force.
Okay, so summing that part up. So WX is basically taking semiconductor packaging from just being a process step and turning it into this new era of integrating whole multi-chip systems, whole computing systems right on the wafer. It's a big shift.
A profound shift, yeah.
But, I mean, something this revolutionary, it never comes easy, right? Breakthroughs always have big hurdles. What are the main challenges TSMC is likely facing with SoW-X?
You're absolutely right. The challenges are pretty substantial. The big ones are yield and then managing power and heat, the thermals.
Okay, yield. Why is that such a big deal here?
Well, think about it. The entire wafer becomes one single super integrated system. So if something goes wrong during manufacturing, one critical error, it could potentially make the whole wafer useless.
The whole thing, not just one chip.
The whole integrated system on that wafer. So this demands just unprecedented levels of manufacturing precision and incredibly stringent yield control. You're managing potential compounding across a much, much larger and denser area.
Right, the stakes are way higher.
Massively higher. And then you've got the power and thermal side. With this level of integration, the power density is enormous. The package itself could be consuming hundreds of watts.
Hundreds? How do you even cool that?
Exactly. It pushes beyond traditional air cooling. You start needing completely new solutions. Things like integrating liquid cooling channels directly into the wafer packaging itself, and developing sophisticated distributed power delivery right across the wafer to keep everything stable.
Okay, so significant technical hurdles. Yield, power, heat. So putting all that together, what does this actually mean for the wider semiconductor industry? How is SoW-X likely to, shake things up across the entire supply chain?
Well, it looks poised to really reshape the industry structure and definitely the collaboration models. It sort of transforms wafer foundries, or at least TSMC initially, from just being chip manufacturers into providers of these one-stop integrated high-performance solutions.
So stronger ties with the big designers.
Undoubtedly. It'll strengthen partnerships between the leading foundries and major design houses, your NVIDIAs, your Apples. But at the same time, it really ramps up the pressure on other foundries and basically forces them to invest heavily in their own advanced packaging capabilities just to try and keep pace. Competition will intensify.
Okay, that makes sense for the business side. What about the technical implications, the opportunities that arise from this level of integration?
Right. So yes, the high integration brings challenges, power density, heat, making process and yield control much more complex, as we said. But successfully tackling those challenges, that unlocks just immense opportunities for high-performance computing.
Right.
And that success then creates a sort of ripple effect or maybe a cascade. It drives significant upgrades and innovation across the board in advanced packaging equipment and new materials manufacturing, in testing and verification tools. The whole ecosystem has to level up.
So if the whole ecosystem levels up, let's zoom out a bit further. How might SoW-X influence the actual applications downstream? Where would we feel the impact?
Okay, good question. So WX's ability to create these really large-scale, really powerful integrated computing platforms, that's going to directly fuel hardware innovation, especially in fields hungry for performance, like AI, like high-performance computing, HPC, and maybe advanced 5G infrastructure, too.
So let's focus on just making one chip faster.
Exactly. The focus shifts. It moves away from optimizing just individual chip designs towards this more comprehensive system integration. And that could lead to entirely new kinds of products, maybe new service models we haven't even thought of yet. Imagine super compact, specialized supercomputers built for specific tasks, driving breakthroughs in scientific research, or autonomous systems, perhaps.
And think beyond just the tech. There's always a geopolitical angle with this kind of really advanced stuff, isn't there?
Oh, absolutely. It's unavoidable. The sheer complexity and, frankly, the indispensable nature of high-end advanced packaging. It has major implications for supply chain geography, for intellectual property security. You see global geopolitical competition heating up, right? Particularly involving the U.S., the EU. Everyone's pushing for more resilient, more secure semiconductor supply chains. They see it as critical infrastructure. So in that context, Taiwan's leading position in advanced packaging, especially with innovations like SoW-X, well, it becomes even more strategically vital on the world stage.
A critical piece of the global puzzle. So, for our listener, maybe someone working in a company somewhere in this tech ecosystem, how can they, or their company, best prepare for this kind of industry transformation that SoW-X seems to signal?
That's the crucial question, isn't it? Companies really need to be proactive here and systemic in their thinking. It's not just about one department. Here are maybe a few key strategies to consider. First, really deeply assess your own capabilities, specifically around packaging and system-level design. Go beyond the usual R&D audit. Look hard at your wafer-level design skills. Is your current packaging infrastructure even remotely compatible with a system-on-wafer world? Or does it need a total rethink? You have to pinpoint precisely where your current processes fall short for this kind of ultra-high integration.
Okay, so a real honest assessment first.
Exactly. Second, you've got to forge truly cross-functional integration teams. Break down those traditional silos. So WX touches everything: process tech, design, thermal management, testing. It's inherently complex. So you need project teams with people from R&D, manufacturing, HR, quality, IT, all working tightly together. Deep communication, coordinated resource allocation. It's essential for this new paradigm.
Makes sense. Integration requires integrated teams. What else?
Third, invest heavily in advanced digital manufacturing and AI. The complexities here: managing yield, controlling heat at this scale. You need serious digital tools. Think AI-driven process monitoring for, sub-nanometer precision. Highly automated inspection, like AOI systems, but scaled for wafer-level defects. Predictive maintenance for these incredibly precise manufacturing lines. These aren't nice-to-haves. They become critical for hitting the required yield and efficiency.
So embracing the digital factory concept, basically.
Pretty much, yeah, but on steroids. Fourth, talent and culture. You need to cultivate cross-domain talent. Your employees have to understand these new packaging platforms, these complex digital tools. So systematic training, talent development programs focusing specifically on cross-domain skills, material science, thermal engineering, AI for manufacturing. And just as important is fostering a corporate culture that genuinely embraces constant change and rapid innovation. Because this field isn't slowing down.
Right. The human element is key.
Absolutely vital. And finally, fifth, develop agile supply chain and ecosystem strategies. The whole industry chain is getting reconfigured. So you need flexible business models, adaptable operational strategies, actively explore deeper collaborations, not just with your usual suppliers, but with advanced packaging equipment makers, novel material developers, cloud platform providers. Build that ecosystem strength to ensure your overall competitiveness and supply chain resilience in this new era.
Okay, so it really sounds like preparing for SoW-X isn't just a technical upgrade checklist. It's about a fundamental shift, becoming more systemic, more cross-departmental, highly flexible, and really focusing on the unique challenges that come with integrating everything at the wafer scale.
You've got it. It's a holistic transformation.
Wow, what an incredible deep dive that was.
Yeah.
Okay, so we've really unpacked SoW-X, what this revolutionary substrate-less packaging tech is, how it's potentially set to redefine system-level integration, and also the significant challenges, right? Yield, power management, heat, big hurdles. We also touched on its impact across the board, industry structure, technical innovation, downstream apps, even the geopolitical side.
Indeed. It really is one of those technologies that forces you to rethink the basic building blocks of how we compute. It pushes the envelope.
Yeah.
So for you, our listener, maybe here's a final thought to chew on, something provocative to consider. How might this packaging as a system philosophy behind SoW-X, how might it not just change what we think a chip is, but fundamentally redefine what we even consider to be a computer over the next decade?
That is a powerful question. Redefining the computer itself, something definitely worth thinking about. We really hope this deep dive has helped you get a handle on this fascinating, evolving field. Until next time.